you guys started building IPFS a long time ago. Like it's like literally 10 years ago, right? It was 2014.
Yeah. It was 10 years. Yeah, exactly. This year is going to be a 10-year anniversary of PL. The 10-year anniversary of the first commit in IPFS was last in December, I think, like December 8th or so.
Yeah, so I'm sure that many people were not even in crypto space, or don't hear about crypto space at that moment. But you guys got like started doing it so early, and I think it was actually like maybe the first DePIN project in the space, and
yeah.
at least it was the first well-known project in the space, like the biggest ICO, the biggest launch of Filecoin. So I'm curious, like why you started working on IPFS early on, like what potential you have seen and why you thought it's important to work on decentralization of data?
Yeah, great question. And IPFS and Filecoin are separate projects. They have different goals. They definitely interconnect. And Filecoin is the whole Filecoin network is a subset of the IPFS network. The IPFS network is the protocol by which you move around the data and so on. But I started working on IPFS because I was encountering a lot of problems in scientific publishing and scientific research where people were spending an enormous amount of time moving around data sets. And I was like, great, like we have BitTorrent and the ability to like distribute content easily. Like we've seen this work for games. We've seen peer-to-peer tech like Skype build like super successful things. We should be able to do this much more easily. We have Git with version control and so on. Let's combine Git and BitTorrent and create like a better distribution system. And that's kind of the beginning of IPFS. However, I've been working a lot on different kind of file systems tech before and doing a lot of research in file systems. And that informed a lot of that gave a much larger possibility space for that tech. And I suddenly realized, oh, wait, you could put websites in this whole thing and make the entire web move around like a Git repo. You can make all web applications be distributed peer-to-peer in this kind of decentralized setting. And that was like super, super powerful. It happened to coincide at the same time with Bitcoin and like the early stages of what eventually became the crypto world or the cryptocurrency world, not the original cryptography world. And that's what kind of gave birth to Filecoin, because I was like, great, like if we have Bitcoin and cryptocurrency, we should be able to incentivize the distribution of the content with a cryptocurrency of some kind. And that was sort of the beginning of what seeded the Filecoin project. In addition, kind of I was super surprised at the time. This was 2013, 2014. I was super surprised at the scale of computation that Bitcoin had amassed at the time. I still think that to this day, the most important graph in the entire crypto industry is the Bitcoin hash rate. It shows you the crazy level of power that comes from just a free-floating incentive structure deployed on the internet. The single incentive structure of the block reward plus the cryptocurrency itself existing and being able to be transacted and having some value, those two things put together gives you one of the largest computing platforms, computing systems on the planet. Now it's totally wasted. It's not doing anything like computationally useful, but that gives you a sense of like the level of power that comes out of it. And so when I saw that, I was like, whoa, this is crazy. You could actually amass a level of computation to rival the massive centralized cloud providers. That's a huge deal. You could actually get proper decentralized, verifiable systems in place at scale. And that's when I started kind of developing the ideas behind Filecoin. And then kind of, that was sort of like the reason for building that project. It's important to keep the project separate for a lot of, kind of composition reasons. Like one part is IPFS is a protocol for addressing and moving around data in a verifiable way. Filecoin is a specific subset of that that's like incentivized. Think of it as like, IPFS maps to HTTP and Filecoin maps to S3. And kind of like the path of building kind of, so this was 2013, this is before 2013 going into 14. This is kind of right as Ethereum is getting built. And super early in the space, I remember going around talking to people about like this entire model, and they were like, "This is crazy! Like you're never gonna amass like more than a petabyte of storage. Like that'll be like huge if you can do that." And look at us now, like exabytes of scale and so on. So yeah, we sort of like helped pioneer what is now called the DePIN category. Before that was called that. At the time, it seemed like you could go, open up the AWS console and look at every single product, sort them by easy to decentralize, and kind of like start in one end and just keep going. That's why I sort of started with storage, because storage is dramatically, as Kyle was saying earlier, storage is dramatically easier than compute. We had to build a bunch of the primitives first. Now you get to write on top of all of the work that a lot of people have been doing for the last 10 years, and now you're getting to decentralized compute, which is much harder to do. And I think that's one of the things that is super compelling about what you guys are doing, is like you have a really good models for how to do this really well at scale.
Yeah. That's very like. What I'm interested in here is that basically, as far as I understand, Filecoin success was enabled by one of these. It was a lot of components to success, but one of the biggest elements was this proof of space-time, this cryptographic, cryptoeconomic system that basically incentivized people to bring storage into a network. And actually, this proof is proof generation is a computation work, right? So you guys started sort of, in order to create a decentralized storage network, you created the computational task, right?
Yeah, that was more in the whoops category of we thought this was going to be way easier category of problems. So the proof of spacetime model is a really cool way of getting verifiability over some amount of storage being stored for a particular amount of time. That's why it's called proof of space time. It's a particular amount of space being used in a particular way for a duration of time. And out of that, you can build slices of space-time and then incentivize the contribution of that over time. So that primitive was key to making the Filecoin block reward actually work in the Bitcoin setting. If you don't have, in proof of space-time is related to a proof of replication, which is a sub-primitive. A proof of replication is a single point check that somebody's storing something. A proof of spacetime is doing this over periods of time to give you kind of the time arrow. And so those verifiability components were critical to be able to do the block reward style incentive structure for Filecoin. And that was the key quintessential requirement to be able to kick off the massive amount of hardware accumulation that Filecoin was able to do in a super fast timescale, right? In a year, we went from the network being 0 bytes to being over an exabyte, which is super crazy in terms of the speed of development and the speed of amassing hardware and services and whatnot. So that just shows you the level of power that you can get out of the incentive structures that DePIN networks can leverage, and you can do that across tons of different domains. And yeah, back to your point around computation. So yeah, we ended up having to build this really complex computational thing because the specific proof of replication that we managed to build, though we tried to simplify it a lot, we couldn't get it simpler than what it currently is. And that just required a huge amount of computation. And so it meant that the requirements for Filecoin service providers included a bunch of GPUs. But they don't need them all the time. They only need them a fraction of the time, which to us became a really useful component because it meant that we could also kick off the accumulation of compute hardware in the Filecoin network in addition to the storage hardware. So we could amass the storage hardware and amass the compute hardware, bring it to the network, and set up a great environment to launch computational networks on top, right? So now you can, all of the storage providers in Filecoin have a ton of GPUs and pretty significant machines that you can then use to run other computational networks. And so that's a really good kind of springboard for you guys, for anyone building compute networks.
Yeah, that's actually what I wanted to touch after. So basically, the interesting thing here is that we switched from useless work that proof of work miners were doing to still cryptoeconomic incentives model, but with much more useful utilization of resources for real purpose, for proving the storage. And now basically all these compute resources were brought by providers to a network, and now they can be utilized for other purposes, right? So,
yep.
Question here. I know you guys now looking more into compute space, into decentralized compute use cases. So how you see this compute landscape?
Yeah. So Yeah, I very much agree with Kyle that compute is the hardest one. So I think it's like storage, then bandwidth, then compute in terms of the difficulty. Compute is harder because of there's kind of like this triangle that you have to worry about. If you want to sort of a collapse of the dimensions around performance into one end of the triangle, if you want to make things verifiable, you unfortunately have to pay that in performance. And if you might want to make things private, that means like encrypt the function that you're going to run, encrypt the data, hopefully encrypt the application of the function and the data. Any one of those incurs additional computational costs. And these do not help each other. Like if you want to make things verifiable, the computational cost that you incur is distinct and separate from the computational cost you incur for privacy. For the most part, there are some constructions that are clever in some places, but this means that you end up in a space where like there's this large triangle with like performance in one of the corners, verifiability, and privacy. And depending on like where you are in that space, you incur orders of magnitude of costs in computation to achieve certain levels of verifiability or certain levels of privacy. To me, that when I sort of was thinking about this like 2-3 years ago, it was super clear that the scale, and by the way, this is only in a decentralized setting. Centralized things don't have this problem because they don't attempt to give you verifiable private computing. They can see everything. They can forge anything. It just doesn't happen because of reputation, and which is why like people trust massive scale brands like Amazon and they're not going to trust random Joe's Compute service down the corner. And that sounds kind of sketchy relative to like a trusted brand like Amazon. But the moment that you solve the verifiability or privacy problem, you can now enable lots of other participants to come into the network and unseat these massive centralized parties. But anyway, in this space, you can spot certain areas that like different technologies exist in different spots in that triangle, right? So like things like optimistic verifiability. So like the optimism style rollup space lives very close to performance. You pay a little bit of computation to verify things. It's not private at all. Things like zero knowledge, like ZK proofs, though the term is zero knowledge, they're primarily used to prove things and verify things. The zero knowledge part is like on the keys that you don't want to leak. So most ZK constructions are used to add verifiability to things, and they don't necessarily give you privacy on the data. Some ZK constructions do. So that's taking steps towards the verifiability and incurring huge computational costs by doing so. There are MPC, like multi-party computation constructions, that do kind of like a mix of you need a certain number of parties computing the thing. They give you some amount of verifiability and privacy. Then there's fully homomorphic encryption, which gives you full privacy, and like that's awesome, but it's like way more computationally expensive. And now there's an additional kind of verifiable FHE, which is even cooler, gives you both verifiability and the full privacy. But that's, again, like more expensive. So each of these spots, because of the scale of cost, in order to use those applications, it really has to matter to your use case and to your application. So it means that there's going to be many different use cases for those areas. And because there are different technologies, and the technologies are not easy to build, there would be many teams building in those pockets. So to me, like that whole triangle is a landscape with different niches that are occupied by different networks, building different technologies, products, and against certain use cases. It is possible in the future somebody might be able to like bring this together and make like a general thing that invokes the specialized special case things. An example of doing this is kind of like how ML today has used a lot of compiler tooling to like abstract out the differences in like algorithms and hardware and so on underneath the hood for the developers. And kind of like you just program in Python and like you don't have to worry about it. But that took like a decade or more of like hard work from a ton of people to like make that happen. And that happened within a highly centralized environment. It's unclear whether this is going to be able to like be bound together. It is possible. I think if things remain super interoperable, then there's going to be a highly decentralized setting with a lot of different participants and in a lot of different networks. But we'll see how it plays out. My sense is either way, you're going to end up with like special purpose technologies, and whether that's like fully different networks in the very long term, or they get kind of like brought together is like a very much kind of a path dependent question. But I do think like at least for the foreseeable future, we won't see any fully general thing actually work, and instead it's like special purpose things that that orient against specific use cases and lean into the advantages of their technological platform. So anyway, yeah, this triangle is like very useful guide. And so that means like for each one of those pockets, there should be like 1 to 2 or 3 significant networks in that area that could be pretty compelling and pretty significant.
Yeah, I actually think that this triangle is like a great thinking of the whole space and like trade-offs that any of compute models can have. And like asking for friend, but like you guys invested in Fluence. So what is special about Fluence? What's caught your eye?
Yeah, so a lot of things. So what I found like super exciting and cool was like one of the things right off the bat that I thought was very compelling was your approach to distributed programming. So actually leaning into good programming languages and programming systems theory into giving people a much better way to program. So this is like all of the stuff in AquaVM and the language and so on. As somebody who's built a lot of distributed systems, I know how horribly difficult it is to program these protocols where you have like components and you have lots of different software that has to run in all these different machines, and they get out of like some people upgrade them, other people don't. You get out of sync. You have to like you have to program in extremely complex environments. And if you kind of massively simplify that and give developers a much easier way of like programming distributed systems, that is a super advantage relative to almost other networks. That gives you like it's a superpower that you can give developers that gives you kind of a huge advantage. So that to me like what seemed like very significant. Another part that I thought was really cool is kind of like actually not getting sucked into the consensus problem and instead saying, no, we're gonna orient towards like more traditional peer-to-peer dynamics and really schedule the computation where it should be. I think there's like hard questions around verifiability there, but if you can like if you can like come up with good models, then they could be like solvable for a set of use cases, and so that seemed like a very compelling thing. And honestly, like the team is super brilliant. Like everyone that I met from Fluence, I was really impressed by, and thought they were thinking very deeply about all of the problems, all of the tech, and so on. So that was like what attracted it to us. One other component I think was we tend to be. I've tried to build a lot of things over the last 10 years in a highly modular way, where each project is kind of like centered around one core set of problems and is well decomposed from others in order to give you pieces that you can then use for other things. So this is why IPFS is its own thing, why Lip2P got extracted out of IPFS to then like now power most of the blockchains in the ecosystem, why Filecoin was a separate project, while tons of different things like that. And I thought the way that you approached a lot of things, both like reusing things like Lip2P and so on, just like connected super well with the rest of that ecosystem. And so that was like a super good additional thing. So that was exciting.
Yeah, we actually got a lot of inspiration from like Protocol Labs approach to like for modularity and like for creating these open pieces that then you can take one of this or like you can compose it and build new stuff. So yeah, like got a lot of inspiration. Also like even economic model how like Filecoin works. It's also got us a lot of thoughts. And so I wanted to ask about another project that you're working on, which is called InterPlanetary Consensus, right? Which is also the computation project, and we actually using it to run Fluence, and I'm gonna touch on it later in my talk. So, like, what's your motivation to work on it? Because like this is consensus-based computing, right? This is different from distributed execution. So, how do you think about?
Yeah. So IPC, which stands for InterPlanetary Consensus, is a project that we've been kind of steering towards for many years now. So after building IPFS and Lip2P and Filecoin, we've gotten a very good view into tons of problems in building things in these distributed, decentralized environments at various scales. And my view has been for many years now that all of Web3 is, like when you calculate all of the computation that's happening in Web3, it's tiny compared to the Web2 world. And everything is super rate limited by being able to orchestrate applications in the way that the cloud does. Meaning, today you can't quite build a consumer product like a social network or something like YouTube or something like Google Docs or whatever, because the underlying infrastructure that developers have is way too complex, and if you try to do like on-chain, off-chain things, you end up building super brittle things that end up like not working. And so we need a developer runtime and developer paradigm that gives devs something very close to Kubernetes or to Docker, where you can super simplify the developer experience of somebody building an application in this environment, so that they can truly focus on solving their problem and not have to, get a PhD in computer science, in distributed systems and cryptography to try and like build their application. And so that led me down a path of realizing that, hey, we really should, for a subset of the computation, areas where you really want to orchestrate programs and computers, you should really just stretch consensus really far and scale blockchains. And then though that consensus can orchestrate other computation, like that does not need to run in consensus, right? So if you think of something like Docker or Kubernetes, think of IPC as like the Kubernetes controller thing that enables you to run a pod with a bunch of programs inside. And then that is connected to a bunch of other machines, and you can decide when you are going to run something and whatnot. So that's kind of like the analogy. Now concretely, what IPC is a framework for writing very modular, highly customizable blockchains, like full chains, where you can decide whether or not it's like a full open chain or a special purpose chain that only carries the programs that you intend to carry. And it gives you the way of connecting chains in a topology with a hierarchy. Meaning you can have like a root L1 chain, and you can derive subnets from that L1 to inherit the security of the L1. And that way move a bunch of the computation into a cheaper, faster environment. One of the other things that you get once you start thinking in subnets is that you can enforce requirements on the parties that join the subnet. So for example, you can create a subnet that is regionally bound. And so you can say, hey, we could have like, you can use this to create, a hierarchy to map to like cloud regions. So for example, you can have, like the L1 representing, Earth level computation. Then, like the L2 would be, something like North America, and L3 would then be like a specific data center in Denver. And so that means you can run an entire blockchain where the computation is just happening in that subnet in that data center and can go at the speed of light there. So that means you can have block times in the 10 to 50 millisecond scale and not have to wait multiple seconds. So that means super fast settlement for all kinds of transactions, which is what you need for things like games and social networks and the real kind of like large scale applications that people use today. So that's kind of the structure for IPC. And it kind of like is born out of like everything that we've learned building IPFS, libp2p, Filecoin. And we're building it, again, in a very modular-oriented way. We're building it as its own separate project that people should be able to use. It builds on FVM, which is the hypervisor that we built for Filecoin, where you can mount many different VM runtimes on top. And so that means that you can have like this customizable structure to be able to like load whatever programs you want. And I'm super like interested in like uses of this where like you can start doing some stuff that seems crazy today to the blockchain industry. And so I think about it in terms of like what revolutionary demos you could show that then like would blow minds, right? Like so things like run a full MMO on a set of subnets where like you have one thing maintaining the state of like a particular like world, and then you have subnets representing a particular region of the space, potentially other subnets representing instances in a dungeon. Or maybe potentially run a full FPS where like 30 ticks a second, you could actually run something like that in this kind of structure. Or a full social network where like every single artifact, every interaction, every like tweet, every reply, every like, every view, all of the little artifacts are sort of like all that shared state is tracked in these subnets. And then you have like the full verifiability rolling up all the way to the root. One key component of this is that you need super easy calling conventions across this landscape. So anyway, that's kind of like what IPC is about, and it's really kind of like an orchestration tooling. It's kind of like saying, let's bring the superpowers of virtualization and large-scale compute orchestration that the cloud sort of pioneered, and mix them with decentralization and verifiability and blockchains, and use the blockchain structure as just like a very powerful decentralized orchestrator to then power all of these other kinds of things. So to your question about like, or to your point about, so that's a consensus layer just orchestrating the machines. Now in the leaves, you can put like large-scale compute nodes that are going to run like single programs. Think of like an LLM or a Gen AI sort of thing, and you can orchestrate them using something like IPC. But you're now doing like the really heavy computational load in the leaf nodes.
Yeah. So you basically like covered a little bit my next question, and one thing that I love specifically about IPC is this nested structure that we can do like subnets under subnets. Like we currently run our just single subnet for Fluence, but there's a way to scale it with setting up more nested subnets. And the funny thing is that actually we are building decentralized compute protocol using another decentralized compute protocol, right? So like that's interesting.
Turtles all the way down.
So from AI perspective, because AI is a hot topic, everyone talks about AI. So we have this consensus-based protocol powered by IPC. We have non-consensus-based network that can run distributed workflows like Fluence. We have Filecoin that has massive amounts of data. So how do you see all of it play together in terms of like onboarding, like empowering AI?
Yeah, like we're basically there in being able to start running pretty significant large-scale models, right? Like we can put the data sets on these networks. We can train the models. We can, once you have the model, you can snapshot it back into the network. You can have full verifiability of like every single artifact and object that you're using along the way. You can run the inference through these networks. So yeah, I think like the components that are there to build this. I think in order to do the LLM and Gen AI workloads, you probably have to do some like special purpose like building here. Like, this is an interesting question for computational networks. Like, how much software, how much like protocol do you need between kind of like a layer like Fluence and maybe like a developer that wants to like deploy an application to like support people going to a website and like entering a prompt and getting an image. Like, do you need another protocol there, or is it basically is the layer now all you need and you're ready to go? I think today you could probably, a set of like pretty experienced devs could probably do it on top of just Fluence. But I wonder if there are like layers there about kind of provenance of like what it means to like train an LLM, what it means to run a thing, what it means to like, there are like some interesting like ML AI specific things that you could kind of like create into standards. So I think we'll see stuff like that in the next year start to emerge in a bunch of places.
Yeah, so it's more like on a UX sort of like DevX sort of level of which sits on top of this low level infrastructure.
Yeah, I think if we want to see this at scale, I think what we should do is like find a particular set of things that currently is like very expensive in the centralized cloud. So it could be like some of the video work, it could be some of the more expensive LLMs, and then try to build a special purpose application that like does it and tries to like and scale it out and see where things are breaking.
That's also super interesting. I believe that these networks can really reshape the AI. We hopefully will reshape the whole AI drama with centralization and like big tech owning it all. With a better price and
Yeah, so this is a pretty interesting space, and I would like maybe add some nuance here where like for a lot of reasons when we think about AI, and especially as we get closer to AGI, these are super capable models that can do, by definition, supposed to be able to do if we get to AGI, arbitrary things that any human can do. Once you get to that level of power, a lot of questions come up in terms of like who gets to build this, who gets to control this, who gets to invoke things. And it is not clearly, like, all options presented in front of us suck in a lot of ways. And both the kind of like hyper-centralized environments are really kind of dangerous in their own ways for a bunch of reasons. Hyper-decentralized environments are also really dangerous for other reasons. So concretely, like, if you give people super capable systems that can do like almost anything and you let anybody invoke them, then you just gave everybody, you like amplify the level of power that any human has. And that can be pretty destructive pretty fast. I'm super optimistic in terms of all of the good that everyone is going to do with that. That's awesome. But I'm also realistic in terms of the harms that are going to come from that. The hyper-centralized structure also presents problems because now you have small groups of people controlling arguably like, you know, a superpower, like a deity almost level result. And that also has a ton of problems because, you know, who gets to decide what's okay to run and not okay to run and so on. So this is an area where, like, I think if blockchains are going to play a significant role here, you know, kind of in addition to kind of cost reductions on the compute side, I think that the best role is in adding very strong provenance and governance structures to be able to decide what we should be running, what models we should be building, and who should get to invoke what. And I think that is an area where we have something very significant to contribute. I would be wary of just deploying like random LLM-powered decentralized networks that anyone can do, where anyone can do anything. That I think is probably going to be more harmful than good at the beginning. And so I think I would like focus on building structures to produce systems that are going to orient and align with what, you know, kind of like what is good for humanity. And I know that's a super hard question, but unfortunately we have to like speed run philosophy to try and morality to figure out like what that means. But we have to like to have good decentralized things that make things better. We have to kind of like solve that coordination governance problem. So yeah,
I'm actually glad that you touched governance question because like we have announcement coming up regarding like very relevant to it. So I guess we almost have no time now, but last maybe like short question. You know, after all these years of building, like 10 years,
yeah.
right? You know, any lesson learned that you can share with, you know, with builders who start building now, or like as us just launching mainnet? So
yeah, so many. Well, so the blanket thing that I see a lot of teams struggle with is just a lot of like startup or product basics. And so I would like strongly recommend all builders to become like master level product builders and startup builders. And that means go learn everything that like all their startup builders and product builders have written about. And so just kind of like ingest all the material out there. Like, you know, take the role of an LLM and go read like all of the stuff that's out there and go watch like good interviews and good biographies and like that kind of like that will make you a dramatically better product builder and a dramatically better startup builder, and you will be able to like speed past like tons of other, you know, problems that were maybe holding you back. Probably 90% of the problems that I tend to, so I currently advise like on the order of, you know, a few hundred companies and over 1,000 projects at this point, and like just 90% of the problems that I see are just fundamental kind of like execution-oriented product and startup building problems. And so like that'll kind of the good news here is like it's not rocket science, it's not like super new, it's all been written down. You just have to like ingest it. Maybe specifically for DEPIN networks, the biggest problem that all DEPIN networks mess up, and like we mess this up in Filecoin, everyone is sort of like messing this up. The supply side is easy to scale up because of the structure of how the crypto economic incentives work, but it's still hard enough to build that you spend most of your time building that. And teams don't focus as much as they need to on the demand side, which is both hard to build and not easy to scale. And so what you end up with is most DEPIN projects spend most of their time doing the super scalable demand thing, the super scalable supply thing, scale up the supply side, and they don't scale up the demand side. And that means like you get these very large networks with a lot of supply and zero demand in terms of or like, significant demand, but like much lower. And so for example, in Filecoin, like we should have done a lot of that demand building like years before mainnet launch. We basically had to start there after launching the network, and now we're like in a super great position, but like it took us a while to get there. And I think like most DePIN networks that I see aren't doing this right. I think that they're like figuring out and solving the supply side and launching without the demand side. And so I would like very, very strongly recommend that all DePIN builders go and like figure out the demand side, like either first or like in parallel with, but like very strongly focus on it. And today we don't have good structures to scale the demand side in a cryptoeconomic incentive sort of way. There's a bunch of good experiments, like Filecoin Plus is a good experiment of that in that environment. This is something that I think is open. I think somebody will probably figure out a good cryptoeconomic way of like scaling the demand side, but it is harder than supply because adding cryptoeconomic incentives to the demand side it's just a way, way, way harder to do in the supply side. So yeah, that would be like my advice. And optimize for good outcomes, like orient towards like everybody around you is like trying to make the world better in some way. Just kind of collaborate with people, build modular things, build on each other's stuff. Like if you see somebody else building the same thing as you, like either join forces or collaborate, or like, great, maybe you don't have to build it, move to the next thing. That's often what I do now. Like when I find, like I want to build something and I find somebody else that's building it, awesome, I don't have to worry about it anymore. I can just go help them and focus on like the next thing. And try to optimize for like making the world a drastically better place. And we are in a really powerful century. So the things that are built in the next few decades are gonna totally transform our civilization. And I encourage you to like take the superpowers that you have and help us make sure that we have a good future.
Awesome, that's great words. I can only like add that like I agree that in Web3 people think that because it's Web3, it's crypto permissionless, we don't need to go after users, they will come, but they will not come. Like you have to work on this. Like you have to work on adoption. You have to go after users. You have to find product market fit. Like that's a work. That's not different from what like in other business areas. Yeah.
Thank you.
Yeah. Thanks, Juan. Super excited. Thank you for joining.